We're going to take a look now at probability, and we're going to do section 6.1 and 6.2 at the same time, because 6.1 is just a short section that kind of gives us an overall feel for what probability is. So let's read it here. It says probability is a numerical description of how likely an event is to occur, or how likely it is that a proposition is to be true. So it's a number between 0 and 1, where roughly speaking 0 indicates it's an impossible event and 1 indicates it's a certain event. So probability is, it says a numerical description. What it means is that probability is a measure of how likely some event or some proposition is to be true. Now we're going to use the capital P just to write probability, and suppose that we did this. I'm just going to call it E for some event. So suppose that the probability of some event is equal to, say, 5/6. So just for example, suppose we have this, that the probability of some event, whatever that event might be, is 5/6. Now that's a number between 0 and 1, and what it means is out of 6 trials, 6 is the denominator, out of 6 times we do this experiment, the event E, whatever it is expected to occur 5 times. So it's expected, no guarantee. It's just how likely something is. So if we do something 6 times, we expect this particular event to occur maybe 5 times. So now we're actually going to go into 6.2. And what we're going to do is talk about probability in terms of sets. So first of all, what we want to do is talk about what the sample space is to some experiment. And why don't we just represent this as a set? So represent it with the capital letter S. And what this is this will be the set of all possible outcomes. So when you perform some experiment, things are going to happen. What we're going to do is we're going to put all those possible things in the sample space. Here's an example. This is problem number 2 from the problem set. It says, a letter is selected at random from the word Mississippi. So describe the sample space for this experiment. So I'm going to write this as S. I'll try. S is equal to, all right, this is the set of all the possible outcomes. So here's the word Mississippi. If you were just to randomly pick a letter out of here, what letters could you possibly get? You could get an M, you could get an I, you could get an S, and you can get a P. Now, it's more likely to get an I, an S, an I or an S than it is an M than it is an M, because there's more I's and S's and P's than M's. But that's not what we're doing right now. We're not assigning numbers. We're just looking for what could possibly happen if you just randomly pick a letter out of the word Mississippi. You could get one of these letters. Now, an event, this is a subset, right? This is a subset of the sample space. So we might call it E. So E would be a subset of the sample space. And in part B here, what we could do is describe the event. The letter chosen is a vowel. Okay, so let's draw a vowel here. So what could happen in the word Mississippi? What are the vowels? I, that's it, right? So the subset would be this. And sure enough, E is a subset of S. So later in 6.3, we'll start finding probabilities of events. Like, what's the probability that you get an I? So, but first we have to have some kind of notation. So here's the sample space. Here's an event. An event is just a subset. We could write another one here. Here's another event. What's the probability, not probability, here's an event. What's the probability you get a consonant? Right? So what's the probability you get a consonant? Well, a consonant would be what? You could get an M, an S, or a P.